In this video, I'm going to explain why ethyne molecule is linear, why it assumes a linear geometry. So I will start by explaining the kind of hybridization that takes place in ethyne, because that is actually the reason why it assumes that shape. That hybridization is called SP hybridization. You know, these are the outermost shell orbitals of carbon having 6 electrons. This is S, this is P. Now, when one electron is promoted to the empty p orbital, we have something like this. Then these orbitals are ready for hybridization. But the hybridization is sp, meaning one s hybridizing with p, one s mixing with p. And we have this. Remember, S is spherical, P is dumbbell. So when spherical shape mixes with dumbbell shape, we have this shape. Then we have 2 unhybridized p orbitals with their shapes intact. Now, the carbon that owns these 4 orbitals is this. So, now these 2 hybridized orbitals, sp, they are sp hybridized. The 2 sp hybridized orbitals will move as far away from each other as possible to minimize electron repulsion, because electrons are like charges, they can't stay together. So in going far away, the farthest they can go creates a linear arrangement. Look at it, linear. You know. Then we have 2 p unhybridized orbitals. These unhybridized orbitals will be perpendicular to themselves and to the linear arrangement. So the first one is perpendicular to this linear arrangement, meaning that one is facing you, one is pointing away from you, just like this. As this hybridized orbital is this way, this one is like this, making angle 90. Now the other unhybridized p will be pointing up and down. Let's say this one is up, down. So that is a carbon. In forming ethyne, it means 2 carbons are involved and 2 hydrogen are involved. So the first carbon will also hybridize its orbitals, like this carbon, and this is that carbon, with its hybridized sp, you know, and this 1 electron. Now, the next is that hydrogen will come with its s orbital. Hydrogen will come with its s orbital. This is hydrogen with 1 electron. Here, hydrogen will also mix here with 1 electron. This particular carbon also has unhybridized p orbital. This one pointing pointing towards you, and this one away from you. Then another one up and down. Now, these unhybridized p orbitals have their electrons intact. So this will form a partial bond, because it's only 1 electron existing in between them, up, and 1 electron existing in between them, down. These 2 partial bonds lead to what is called pi bond, which is not a strong bond, because these things keep moving. Electrons keep moving up and down, creating a pi bond. The same thing happens with the second unhybridized p orbital, creating another pi bond. In all, we now have carbon with a sigma bond formed in between 2 hybridized orbitals, and 2 additional pi bonds with hydrogen. And if you see this, it is a linear shape. If you study this, you see that it has assumed a linear shape because of the way the hybridized orbitals arranged themselves.